Welcome to Best Academy TV. In this video, we're going to focus on electric potential and potential difference. Before we solve some questions here on electric potential, let's take the definition of electric potential. Please write. Electric potential can be defined as the work done per unit charge. Electric potential can be defined as the work done per unit charge. Full stop there. Let's represent the definition in a mathematical expression. Mathematically here, okay? Electric potential V is equal to W over Q. Okay? The V here represents electric potential. The W here represents work done, and work done can either be potential energy or kinetic energy. Please don't forget the unit is in joules. The Q here represents charge, and the unit is in coulombs. So the unit of potential difference can be expressed as joules per coulombs or in volts. Please take note. The unit of electric potential can be expressed as joules per coulombs or in volts. Please don't forget. Let's look into electric potential difference, then solve some questions. Please write electric potential difference. Electric potential difference. Electric potential difference can be defined as the change in electric potential energy. Electric potential difference can be defined as the change in electric potential energy per unit charge of a charged particle. Per unit charge of a charged particle between 2 points in a region. Let's represent this. Okay, mathematically, VB minus VA is equal to W into A to B over Q. This here represents the difference in electric potential, while this here represents the external work done, that is from A to B, and this represents the charge. Please take note. All right, let's consider question 1 here to understand the formulas perfectly. Question 1, please. Let's solve this question here. Question 1, they said if the electric potential difference between 2 points A and B is equal to 42 volts, find the work done by an external agent in carrying a charge Q equal to 5 times 10 raised to of minus 5 coulombs from A to B at a constant speed. We are asked to find the work done by an external agent in this question here. But before we solve this here, we have to represent the potential in the electric potential difference relating work done. The formula for solution first. The formula for electric potential difference related to work done is this VB minus VA is equal to work done, that is W of A moving to B over Q. Please don't forget, we have various formula for electric potential difference, but whenever work done is given, we apply this particular formula here. Don't forget, okay? So from the equation given to us here, let's represent the given parameters here, or the parameters given to us in the equation is the first one here is electric potential difference, which is VB minus VA is equal to 42 volts, and the charge here is given to us as 5 times 10 to the power of 5 minus 5 coulombs, and we're asked to find the work done, the external work done. Please take note of this. So let's replace the parameters here. When you replace the parameters here, this will be 42 is equal to class work done A to B over 5 times 10 to the power of minus 5, making work done the subject of formula here. Work done will be equal to 42 times 5 times 10 to the power of minus 5. So punch your calculator here. I will have this to be 2, that is 42 times 5 give us 210 times 10 to the power of minus 5. Making everything to be in standard form, I will have this to be class 2 from here to be in standard form only. This is going to be class 2.1 times 10 to the power of 1 2 times 10 to the power of minus 5. From the law of indices, this is 10 and this is 10. You take only one. You take only one of the 10 here and add up their powers. So when you do so, work done will be equal to 2.1 times 10 to the power of 2 minus 5 will give us minus 3. And the unit for work done is joules. Please take note. This is our answer here. So let's solve question 2 here to understand this perfectly. Question 2, please. Let's solve question 2 here. Question 2, they said, find the potential difference required to give a helium nucleus. The charge here is given to us as 3.2 times 10 to the power minus 19 coulombs, and the kinetic energy, which is this, is given to us as 48 times 10 to the power of 3 electron volts. So we have to change this electron volt here to joules, since we are solving in kinetic energy, not in photon energy, okay? If it's in a photon energy, the unit of energy will be electron volts. But if the equation is not in photon energy, the unit of energy will be joules. Please pay much attention here. Okay, now let's solve this question here, class. Solution. From the question here, we are given Q, that is the charge here, 3.2 times 10 raised power minus 19 coulombs, and the work done, that is the external work done here, that is moving from A to B, okay, is 48 times 10 raised power of 3 electron volts. So our intention here, this is already in SI unit. So our intention here is to change this to joules, okay? That is the proper SI unit. How do we change from electron volt to joules? Now, to change from electron volt to joules here, this is what you have to know, that 1 electron volt here, from the conversion, that 1 electron volt is equal to 1.6 times 10 raised to the power of minus 19 joules. So this is the fundamental relationship between electron volt here, which is this, and to that of energy, which is this. If that is so here, class, okay, please open your eyes here. If that is so here, but before we convert fully here, I want to illustrate on this. If I have something like this, 2s like this can also be interpreted as 2 times 1s, though we don't have anything like 1s. But this can be interpreted as this, right? If you multiply this 2 times 1s here, you have 2s. So the same thing applicable to this here, class. If I have this to be 48 times 10 to the power of 3, 10 to the power of 3 electron volt, this can also be interpreted as 48 times 10 to the power of 3 times 1 electron volt. All right. So if that is so here, our work done will be equal to class 48 times 10 to the power of 3 times 1 electron volt. And whenever we see 1 electron volt, we replace that as in terms of joules, we replace that as 1.6 times 10 to the power minus 19, right? Okay, when you do that here, this will be equal to class 48 times 10 raised to the power of 3 times 1.6 times 10 raised to the power of minus 19 in joules. So class, convert this fully here. I will have this to be 7.68 times 10 raised to the power of minus 15 joules. This is our conversion here. So we have successfully converted the electron volt to joules. We can now use the value to calculate for potential difference. So let's use the value here to calculate for potential difference. From the formula here, potential difference VB minus VA is equal to work done, that is external work done here, over Q. Please don't forget, will be equal to, let's replace this 7.68 times 10 raised to the power of minus 15 over the charge here is 3.2 times 10 raised to the power of minus 19. Okay, let's evaluate this. Divide by this. I will have this to be class 2.4 times 10 raised to the power of minus 15. Taking minus 19 from denominator to numerator, it will be plus 19. So finally here, this will be 2.4 times 10 raised to the power of minus 15 plus 19 will give us 4. And the unit of this here, potential difference, is either joules per coulombs or volt. So we use volt here. Okay, either joules per coulomb or volt. Okay, so in our next video, we'll consider electric potential due to a single point. We'll consider electric potential due to a single point. All you have to do to get the full video here is to hit the subscribe button. Make sure you hit the subscribe button. It's only for those that have subscribed.